Alright guys, inscribed angles. This should be an easy one and a quick one. Every time we do inscribed angles and you see an inscribed angle, that is where, just so we're clear, our vertex here is on the edge of the circle. And you see this lovely angle here, CAB or BAC. We want you to think of multiplying by 2 or dividing by 2. It just depends on which way you're going. This first one, easy. We have angle here 114. And with these inscribed angles, it's just going to get bigger. I almost think of a greater or less than symbol, right? This kind of looks like that. This is the smaller side. The smaller number opens up to this big arc over here, which is the bigger number. So we're going to go 114. That's going to double for BDC. That's the arc we're asking you to find. And that's very simply going to be 228. 228 degrees. Alright, second guy here, same thing, inscribe, double, or take half of it. If you're not careful, you're quickly going to put down 185 and get the answer wrong. We're looking for angle ABC, and if you think angle arc ABC, you're going to add these two numbers together and get 185. It's going to be totally wrong. You have to find it that we're going angle ABC, this here. And in order to know this angle, you must know this arc. And with a number of these problems, there is a bunch of this subtracting thing. So we all know that the number of degrees in a circle would be 360. And I like to joke in my one class to say that, well, if I'm looking for this stuff around the outside, can I walk this area? And this number here is sort of the key. Like, does this key unlock the door to let me walk through this area? Yes, it does. Then do I know this amount? Yes, I do. I know 105. And then I kind of get stopped. Like, well, I can't go any farther. So what I like to say is let's add the 105 and the 80. And let's get 185. Then let's subtract that from whatever the total is all the way around the circle. We get 175. And all we found there was this big old arc over here, right? Because we did 360 for all the way around. We went here, here, and then we just found this 175 here. So might as well write it out there just so we see it, 175 for the whole thing. And then I really like saying in classes, in order to do these inscribed angles, you need to take your fat little fingers and you need to put them one here for this A, because it's making this arc, and one here for this C. And take, I can't do it on here, but take your fat little fingers and go from C to B and from A to B. And you see how this big arc here goes straight back to this angle? That's the angle that is half of this number here. So we're going to divide our 175 by 2 and we get 87 and a half. Angle ABC, 87, hey, that's a horrible 87. 87 and a half degrees. Alright, another inscribed angle, of course. I know that because we have this vertex right here on the edge of the circle. So we have this angle here like this. We have that vertex on the edge. This is one of the scariest looking ones, but this is just as easy as the first one we did, where we're simply just going to double the number. Don't let it freak you out. Notice it's inscribed. And then go from G all the way around the H and back around to J. And that's what we're asking you to find, is arc GHJ. So we're going to go from here all the way around. That big arc meets back up at this angle of 140. And what did I say, right? The angle is smaller than the arc, so the angle is 140. Simply double it, and you have your arc of 280 degrees. Can't tell you, I can't stress enough how much these ones just freak you guys out. Going from J again, going backwards, H to G. Alright, next one that kind of freaks people out. We have a heck of a lot going on. Looks like we have a couple triangles inside, but we don't. Ignore them. We have these two inscribed angles, and I've done two of these here. One over here on the right and one over here on the left. And the one on the left is how it would look on paper, right? Just all black and white, or yellow. This guy over here, I color coded a little bit to help us out. This blue highlighted arc is our intercepted arc. And my point is, if you take your, again, fat little fingers and take your arc and go from E back, you end up at D. If you go from H back, you end up at D. So that means, again, like the first example, this 47 degrees relates to this arc. And we're ignoring this entirely, ignoring these red lines entirely. But from 47 all the way out to this arc, it's going to tell us that this guy is what, 92? That'd be nice if I did that right. How about 94 degrees? 94 degrees. Now, looking at the other guy, same little deal here. Taken from E, going back this way, and then taken from H and going back this way. It's just a funny, they're two inscribed angles that meet up at the same arc, hence the word intercepted arc. It's intercepting the two angles. So this guy here ends up being 47 degrees, just the same as the other guy, because they meet at the same arc of 94 degrees. So you get this black and white picture, either try to color code it or something for yourself, or again, try to use your fingers to follow it back to where these angles meet. Just on a hint, on a note, I knew to go this way, guys, because there are no numbers over here in E and H, so I could care less if I go this way. Okay? Alright guys, last one. Remember, with all these, you get stuck, use your circle wheel, your little pie pieces on your circle wheel. This guy on the left, that's how it's going to look in class. What I see here is a circle with an inscribed quadrilateral, right? Just like the inscribed angle from before. We have a quadrilateral with the vertices touching on these corners here. No big deal. There's two ways of solving this. You pick which one you like. I kind of broke the pictures down over here to maybe show you and make this a little easier for everyone. Ultimately, we need to find arc BCD. BCD. Now, if you look carefully over at my examples over here, BCD goes back to the X. And it's just one simple inscribed angle. I got rid of all the other stuff. So if you can figure out X, you can double it to get BCD. No harm, no foul, no big deal whatsoever. Now, we have this 100 degrees here. The other way of solving it, with your quadrilaterals, hopefully you remember, these two guys add up to 180. So if this guy's 100, this guy over here is 80 degrees. That's my X, 80 degrees. Voila. I have my 80 degrees. If I follow it out right, I come back to BCD. All I have to do is double it. I end up with an arc of 160 degrees. Oops, sorry. Now the other way, if you so choose. You can take your 100 degrees. Now I'm on this little example here. You see it opens up to BAD. Well, just like before, small number opens up to big number of 200 degrees, right? I'm just doubling it. We talked about that. Small number of the angle, when it's inscribed, opens up to double that for the arc. But we all know there's 360 degrees around this guy. And if we just found this, change colors here for us. If we just found this as 200 degrees, what do we need to go the rest of the way around? Right? How about 360 as in the whole way around the drawing minus 200 degrees leaves us with 160 degrees. It's up to you. Either way will work. Remember, circle wheel.